If you don't know, raise your hand. Oh, this is great. This is fantastic. You don't know. Here we go.
So Dom's lying. He does know. So Scenic City Summit is going to be our second year. We're actually going to be at the convention center. For those of you, anybody remember DevLink? Okay. Not DevLink, continuing in the spirit. And we are going to have, we're aiming for a couple of different tracks this year. We're going to have, I think, about 5 different rooms. We're in the middle of speaker selection right now. Friday the 28th, one day. Early bird registrations are open-ish. We're having a little bit of an issue with our payment processor. We're working that out with Extreme Prejudice today. Yeah, any questions, ping me or Greg Ostermeyer, Stuart Dickerson, any of those people. Yeah.
There we go. All right, so without further stalling, give it up for our wonderful speaker for today. Round of applause.
Well, thank you. Hey, the mic works. That's new. Thanks to Brett and everyone for organizing this and for having me out here. Appreciate the time. My talk today is, about Kubernetes and specifically about keeping your services on Kubernetes available and running. I've designed this talk, I hope, so that everyone can get something out of it, whether you're already running Kubernetes or you haven't touched Kubernetes or don't even know what it is. Hopefully there's something in here for you. And as much as this is about keeping things running on Kubernetes, at the end I just blow everything up. So we get to watch things explode too. Not literally, but it'll be fun, I hope. That's my name. You can follow me on Twitter at Robert J. Scott. You'll see slides online there later. That's my website. We'll be using that kind of today, and I'll be destroying it later today. But yeah. I work with a great team at Spire, some great people here today even, and you can get to our website at spire.me. And I think today our Spire Twitter handle got verified, so we're kind of famous, you know. But anyone remember this? Back February 28, I think, there was this big S3 outage and just general AWS service disruption. Is anyone on AWS with their infrastructure? If you're at Spire, you can raise your hand too. Yeah. So yes. Yeah, that was a scary little moment, and a lot of things went down. The main part of this was an S3 outage, and we had anything we relied on in S3 was already backed up with CloudFront, so we were mostly okay. But there were other parts to that. I imagine a lot of people during that day looked kind of like this if they were on an ops team, just running around, panic, whatever. But all our systems were still up. We were just trying to figure out why all our systems were still up. When we saw that graphic, we saw that status page, and things looked like they should be down. So our systems are still up. We're trying to figure out why, and generally just relieved, right? I promise this is my last GIF. I promise. Not so fast, though. An hour or two into this, we noticed that one of our EC2 instances failed. You know, that's something like that would usually be somewhat concerning. Especially because during this outage, you couldn't create anything new on EC2. So we had something like that just went away and died, and we couldn't replace it. In our old system, it would look kind of like this. We had built in some kind of redundancy. Our system wasn't terrible, but there were places where there weren't redundancy, and especially if you couldn't replace a server, you'd be hurting, to say the least. On the other hand, Kubernetes, I forgot this was a GIF. I promised this is it. Okay. But Kubernetes just kept on running, and we were okay. So all Spire systems were still up after this instance failure, after it just kind of died and went away. So all we were doing during this time is watching what was happening. We didn't do anything actively to keep Spire systems up. We just watched Kubernetes work its magic. So what exactly happened to keep our systems running through all this? To understand kind of what is behind Spire, what's powering Spire, we've got a bunch of different services. And I have simplified this a bit, and we have creative little names for these guys, but I'm not going to whatever. This is a better description of what we've got going on. So we've got an API, we've got a website, we've got a management portal, and those are kind of core HTTP services that are exposed to the world. And then we've got background services like a scheduler that releases things like challenges and rewards. We have background processing that's just kind of number crunching, aggregations, that kind of thing. And then we've got a notification service that's pretty self-explanatory. And we have this same concept across lots of different environments. So we have, let's say, a demo environment, a staging environment, a QA environment. We have lots of different environments that we're running these same services across. So Kubernetes, the way it splits it up, and again, this is kind of an oversimplification, but let's say we have one cluster that runs our demo, our staging, and our QA services. So you can see across 4 different nodes, all these services are kind of spread out, so they're redundant. So in this case, what happened is we had node 4 fail. You can see, okay, we've got, right at the top there, we've got a staging management portal. And that went away, no longer working, but looky there, we've got another staging management portal on a node that's still working. Let's look at our QA website. That went away on node 4, but we've still got it hanging out here somewhere else, over here on node 1. And you can kind of see that, again, this is not exactly what happened, but this gives you an idea. We actually had over 20 containers running on this node that failed. And everything just kind of, first, the traffic stopped getting sent to the failed node. And then second, all the containers that were on that node were automatically migrated over to the nodes that were working. So we had enough extra capacity on our other working nodes in different availability zones that it went from this kind of failed node situation, everything on here moves over to our working nodes. And eventually, 2-3 hours later, Kubernetes was able to get a new node spun up when the instance was over and things had kind of resolved. But during that time, if we didn't have a system like Kubernetes that was modular, we would have had some specific services that were completely down. So avoiding at least a few hours of downtime with Kubernetes, just kind of migrating everything over. And remember, we did nothing here. We just watched. It just happened. And that's kind of the magic of Kubernetes. So I've got some kind of analogy here, and this is not perfect, but I just wanted to. You've heard a lot of terms in this ecosystem, I'm sure. You've probably heard of Kubernetes. You've probably heard of Mesos. You've probably heard of Docker, and if you're not completely familiar with this ecosystem, you may not understand exactly how they all fit together and what each is responsible for. So I'm going to try and cover how everything fits together. So I like to think of a container ship being most similar to Kubernetes as some kind of orchestration tool. This container ship keeps your pods, all your containers running. It's responsible for figuring out where your new containers should go and getting rid of your old containers as you no longer need them. So at its base level, we're going to think of Kubernetes as something like a container ship. But Kubernetes is not alone in this space. Kubernetes is one of the newest and most popular tools, but there's also Mesos, and there's also Docker Swarm that would be generally competitors to Kubernetes in this space. But, okay, I got to prefix these next 2 charts with, this does not mean as much as you may think. But the trend, I'm just going to show you some charts about trends. And popularity doesn't mean a product is good. And no popularity doesn't mean a product is bad. But there's at least increasing interest in Kubernetes. So this is a Google Trends chart showing interest in Kubernetes, Mesos, and Docker Swarm over the past few years. And you can see Kubernetes has really shot up. Kubernetes is only 2-3 years old, and it's already just taken off. Then we're going to go to a more dramatic, and again, this is not a perfect metric for anything, but we're going to look at GitHub stars next. And this is, the blue is Kubernetes, and their stars over the past almost 3 years now, compared with Docker Swarm and Mesos below. So you can see there's some kind of trend between an interest in Kubernetes. That doesn't mean it's a great product. I think it is, but there's some interest there. So we've got our container ship, but we need a way to build it. So we need some kind of provisioning tool. We need a shipyard in this analogy. Some of the most popular provisioning tools, you've probably heard these names before. There's Ansible, there's Terraform, there's CloudFormation. And these aren't specific to Kubernetes. These just provision infrastructure and can be used to provision Kubernetes. And then there's some Kubernetes-specific tools, kops and cargo, that can be used to provision not just your infrastructure for Kubernetes, but also Kubernetes on top of that. Okay, so we also need a place to store all our containers. Over time, these just kind of build up and build up and build up. So I like to think of a container registry looking something like that in this world. And there is a lot of options in this. There's a lot of competition. I really, really love Quay. They're by a company called CoreOS. Docker as a company offers its own option called Docker Hub. And then Google Cloud, AWS, both have their own internal offerings that you can use integrated to store your containers. Yeah. And I couldn't come up with something creative here, so container, I don't know, whatever. But there's a few different container implementations. I've highlighted here Docker, which is like far and away the most popular, most used in this space. But there's also Rocket, which is a newer competitor that is supported by Kubernetes. And there are more container implementations that are coming up. So hopefully, Kubernetes is often associated with Docker, and that's because 99% of people use Kubernetes with Docker. But you don't have to. Docker is not necessarily a dependency on Kubernetes. They don't have to be connected to each other. So just so you can get an idea of what this could look like, we use kops to provision our infrastructure. We use Kubernetes as our orchestration tool. We use Docker as our container implementation. And we use AWS to store everything. We are actually moving to Terraform for provisioning and Quay for container storage. And I would be remiss if I didn't point out, kops is a really neat kind of provisioning tool in that it lets you print out Terraform output, which you can then kind of customize yourself. And so if you want a good starting point for Terraform to provision things, you can use kops and get to Terraform eventually from that. So it's a great starting point for a Kubernetes infrastructure. Okay, so we're getting close to live demo time, which I've been told is a terrible idea. So if it all breaks, I'm sorry. We'll see. But before I get there, I wanted to at least get through some of the key vocab that I'll be covering in the demo itself. So first off, Kubernetes has this concept of a pod, which is the smallest possible Kubernetes component. It wraps a container, potentially more than one container, but in general, it's this small unit that contains containers. A deployment takes this one step further. A deployment manages your pods. So a pod on its own is kind of independent and works on its own. A deployment can say, I want 3 replicas of this pod. If one of these pods dies, replace it. When I'm updating this deployment, it will do an automatic rolling update for you. So it will keep some living while some of the old ones living while it brings up new ones. So deployment is really powerful. We're going to be getting into that in the demo. And the service. A service is a key Kubernetes concept, and that's, so you have these pods, you have this deployment running on your cluster. You need some way to actually communicate with it. You need some way to expose it to the outside world. And a service can do that. If you're on AWS or Azure or Google Cloud, if you define a load balancer service, Kubernetes will create and manage on AWS an elastic load balancer for you that will communicate with your pods, that will send traffic through to your pods. And a namespace is just kind of a logical way to separate environments. If you remember way back when I was talking about how we had a staging environment, a QA environment, and a dev environment, a demo environment, each one of those would be a different namespace. So it allows you to run the same services, but in its own kind of somewhat isolated world. I'll add one more note. Namespaces by themselves are not completely isolated, but you can do more to make them completely, well, closer to isolated. Okay, so here comes the live demo. Hopefully I don't break things. We'll see. It worked in real life, but you know. So the first thing I'll do is a command called kubectl get pods. And I'm just going to watch that because that's basically the easiest way to, and PO is short form for pods. And so every 2 seconds, it's just going to call that command. And right now, I've got no pods. I've got nothing running on Kubernetes right now in this namespace. And every 2 seconds, it's going to do that call. And so hopefully, as we go through this demo, you're going to see pods spin up here, and then pods eventually die here. And then up here, can everyone see the text here? Is this big enough? Oh, okay. Maybe a bit bigger? Okay. All right, we'll go back. Okay, here we go. All right, so the first, I kind of cheated here a little bit. I actually have a little bit running on this cluster already, so I'll show you what that is. Wow, okay. So I've got a namespace running, and this helps you, yeah, I can make that a bit bigger. Okay, sure. So this is the very basic concept of a namespace in Kubernetes. You see there's an API version, there's a kind that's namespace in this case, and there's a name which is cha-dev demo. And this is where everything will spin up in this demo. Very simple. You're going to see a lot more YAML throughout this demo, and that's how Kubernetes works. You define a state that you want, and then you simply type kubectl apply with this state, and Kubernetes will do whatever it takes to reach that state. So again, we'll go ahead, and there's one other thing, and this was the key. I wanted to set up a service beforehand. So this is what the service looks like that I have set up. So API version, kind of service. Again, the name is cha-dev demo. And this little bit right here, you see how app is cha-dev demo? This tells it which pods to look for. So when we get to the next step, you're going to see a lot of app cha-dev demo. And that basically says, I want this service to send traffic to me. So app cha-dev demo, and I'm going to say accept traffic on port 80 and send it to port 3000 on my pods. Okay, so let's actually spin something up. So this is the very, very basic idea of a pod in Kubernetes. This is, again, just kind of that container system. So you've got kind pod. You remember this label here? This is how the service knows to send traffic to it. So app cha-dev demo. And I created a really simple, stupid HTTP server that is really going to do nothing but send some plain text back to prove that it works. But let's go ahead and do this for the first time. So kubectl apply. I'm going to do -f. And this is 01, simple pod. Okay, so down here below, eventually, okay, there it is. We've got simple pod running. We have one of them running, and it's ready, at least in its thinking. So we'll see here if this worked. Yeah, okay. So chadev.robertjscott.ca. Feel free to try this out on your own, but I will be deleting this, so it'll break for you shortly. But that's a proof of concept. It works, kind of. But let's say something happens to this pod. Let's say, I don't know, it crashes, or somebody is just dumb and deletes it like I'm about to be. So I'm going to kubectl delete pod. And I've got this name down here, so I'm just going to delete the pod that's called simple pod. And it'll take a little bit of time. It'll go to terminating, and it'll still serve traffic for a few more seconds, and it'll eventually die off. And again, if you go to chadev.robertjscott.ca shortly, there'll be nothing there all over again. Okay, so why did I delete that pod? I wanted to get into deployments, because deployments can be a lot more robust, a lot more redundant, and actually help keep your stuff running. So the second part of this is this simple deployment. Oh, well, okay, so before I go there, you can see this is timing out now. This request will fail. That's what I wanted. The pod's not running anymore. Sure. So you saw it just kind of fall off the bottom there. Okay, so I kind of had to expand this because our deployments are going to start to get a little bit more advanced. I've got a deployment going on here. It's actually got 10 replicas, which is just insane and whatever, but I'm going to do 10 replicas. And I'm going to do, again, CHA-dev demo as the app. Everything down here is the same. The only thing that really changed is I added 10 replicas. So we'll go ahead and we'll apply that. And wow, did not want that, but let's see how this works. Okay, so hopefully pretty soon, yeah, they're all up here. They're creating within, and I should warn you, like, this is running on an incredibly weak Kubernetes cluster. It's just a personal GKE cluster, so if it's slow, it's not really Kubernetes' fault. It's just that I didn't put much hardware behind this. Okay, so CHA-dev is back up, chadev.robertjscott.ca, and we've got 10 of these running. Let's just say, because we've got so many open, let me go ahead and, okay. I'm going to delete one of these. So kubectl delete pod. I'm going to take one of these names, and I'm going to get rid of it. So it'd be the same thing if one of these crashed or something like that. Notice right away this guy's terminating, but all of a sudden we had another one spin up. So we're always going to have that consistent number of 10 that we want. So if I go in here and I say, I don't want 10 anymore, I want 3 seems like a good number. 10's kind of overkill. So I'm going to go ahead and save that, and we'll apply this all over again. And right away, you should notice a whole bunch of these are terminating, but it kept 3 running. We'll get there eventually. And again, CHA-dev is still up and running. So this is the whole idea behind Kubernetes. You apply a state, and it'll make sure it stays in that state. So you want 3 replicas running, it'll make sure you have 3 replicas running. Eventually, these other ones will fall off, and we'll have 3 replicas running, and the rest will be gone. Okay, now that's all about well and good, but we need to start getting into some more advanced stuff. Again, we'll pull this down because this is a little bit different. This is very similar to the last deployment that we just came from, except you notice I'm using a different image this time. I'm using something called demo HTTP server. And this is another server I created, but it's a little bit more advanced, I guess. It allows you to break it, among other things. And I like to try breaking things to explain how this can work and how it can save you from bad software, I guess. Not that anyone ever writes things that break, but if you did, Kubernetes could help you out. So we'll go ahead and we're going to apply this version here with the new container. So I want 03, and we'll pull this guy back up. Okay, and you can see what's happening. It's terminating the old pods, and we have 3 new pods spinning back up in their place. And in this process, if we go over here, eventually you can see it still has hello CHA-dev because these old ones still haven't come out of rotation. But when they do, which hopefully will be relatively soon, we're going to start getting a different message on that site. One day. Okay. So I was thinking about it. I'll get this guy ready. Okay, so this is our demo server. This is 200, everything looks good, which is, I changed the message so that I could try something out like this here. So if I just, let's just say you had a route on your site that could just crash it. I mean, if you were just terrible, and I don't know if anyone has something like that just crashes things, but that's what it does, right? So eventually, you'll see a pod in error state, and okay, it's trying to restart it, and eventually it'll try and recover from this. Crash loop back off, it's thinking about it. Okay, it's back up and running. So now if we, oh well, now I went refresh the crash. So I crashed it all over again. I'm not doing very good here. Okay, so Now we're all in error state. I've been crashing everything, and apparently other people are crashing things too at this point. But I mean, I kind of expected that would happen. So, you know, whatever. Okay, so I got one running. Yeah, okay, so we're back up and running. Kubernetes, you can see, it restarted these a few times because if I were at a live demo, I'd do the same thing and crash, you know, whatever. But that's an example of how Kubernetes can say, okay, this whole container crashed. I'm going to try and fix it. And so it restarts and it restarts. Let's take a look at one of these pods. Hopefully. So one of the commands you can do is kubectl describe to see what's going on in Kubernetes mind. Oh yes, I need a pod. We'll get there. Okay. Sure. Okay, so this gives you kind of this log of what Kubernetes is doing with a specific container. And the key here is back off, restarting failed container. Kubernetes is not going to get yourself into this reboot loop where it tries to restart containers over and over again as they fail. The first time, I think it waits 10 seconds. So your container crashes. In 10 seconds, it's going to restart your container. If it crashes again, it's going to wait 20 seconds. If it crashes again, it's going to wait 40 seconds. If it crashes again, you get the picture. It's going to keep on backing off and backing off so you don't just consume system resources, restarting, when there's maybe no hope for this container. So it gradually backs off, and that's why there's a bit of a delay there in recovery. Okay, so let's look at sometimes your app doesn't just crash, it stops, but the service is still running. The container is still running, but it's not working the way you want it to. No, I got a step ahead of myself. I'm actually on 4 now. Okay, so we gotta crank this thing down again because demos are big. Okay, so this guy added just a little bit. Everything else is the same, I promise. The only thing I'm adding here is a concept called a liveness probe. So this helps in the instance that your container crashed. Well, it didn't crash. It stopped working the way you wanted it to. But it's still running somehow. So let's say it loses a connection. There's some kind of bug. It needs a restart, but Kubernetes doesn't know because the container's still running. Your service is still running. It's just not running the way you want it to. So that's where you get into something like a liveness probe. So in this case, it's going to do a get on /alive. Again, on port 3000, and it's going to try and do that every 5 seconds. And if it gets something that's not a 200-ish response, or if it takes more than 1 second to respond, it's going to consider it a failure. So we're going to go ahead and roll this guy out. So apply, and this is, I think, 4. Yeah, okay. So again, you're going to see this. You've got some new containers creating. You've got some old ones terminating. But in general, we should still see the same thing. Now, what's going to happen here, and this one you're going to have to be a little bit patient for as well. But we're going to go to /fail. And this guy is just going to get this specific pod into a failed state where I don't know what happened to it, but it's just going to return 500 from now and forever. Always, whatever, it's broken. So that's what's going to return from the 500, from the liveness probe there. So eventually, and you kind of have to have some patience here, one of these pods is going to restart. It'll take a while first for Kubernetes to recognize, hey, this pod is not responding with a 200, and then to take the action to actually restart that pod. And yeah, so sometimes that takes some time. I really do believe it'll happen eventually. If not, well, that's live demos for you. Okay, yeah, thank you for cooperating. We got this guy to restart. And so if we come back over here, okay, 200, everything looks good. So that gives you an idea of what could happen if one of your services broke momentarily just for some bad reason. It'll again try and restart it. Again, this container didn't crash. It was still running. It wasn't working as you wanted it to. Another thing that a lot of people have to deal with is slow starting services. I don't know if any of you have services that may take a few seconds, hopefully not 20 seconds to start, but one of my features in this demo server is I can say, take 20 seconds to start up just so we can simulate a really slow server. So I'm going to take this version out here, and we're going to apply this. So these servers are going to take 20 seconds to start up. So we got the new ones coming up, and it's terminating the old ones right away. So hopefully, again, emphasis on hopefully, we'll catch a period in here where these guys are still terminating, but before these guys have gotten past 20 seconds of running and have really started up, where we get some downtime. So maybe eventually. Not quite yet. Get there. Well, so, yeah. Okay, so that age over there is confusing because that doesn't include the time it actually has been running. It's since it started pulling the image and then actually starting it up and whatever. But apparently my time wasn't fast enough. But if you can imagine some downtime in between, that's what would happen. Just imagine this all breaking and being terrible. Yeah, I'm not going to go there. So I'm going to go ahead and show you the solution to the problem that I didn't show. Whatever. We have something in Kubernetes called readiness probes. And just like liveness probes, they have the same syntax. It can be a get on a route, and it has every 5 seconds, and it will time out if the response takes more than 1 second to respond. So that's all well and good, but there's also one very important change I made to this liveness probe. You see how I added initial delay seconds 30? If I didn't have that, the liveness, and I actually experienced this a few times, the liveness probe would get into this, okay, it's checking right away, it's not running, I'm going to try and restart the container. Okay, it's not running, I'm going to try and restart the container, and we get into this failure loop before it ever deployed anything. So you don't want that. You want to make sure your liveness probe waits long enough for your container to actually start running. So we're going to go ahead and we will apply 06. And this is the one with liveness and ready. Oh, yes, I need -F. Okay, so pay attention down here. This is one of the beautiful things about Kubernetes. See, it spun up 2 new containers. They're not ready yet, and it's terminating 1 old container. So this is kind of how the rolling deployment can work. It's leaving some of your old containers around, and it's still spinning up and waiting for this new containers to be ready. And whenever they pass that readiness probe, which should be coming up pretty soon, you're going to notice this transition. So these guys are running, and it's terminating all the old nodes, so the other 2 old nodes, and it's spinning up 1 more, because again, we want 3. So it's spinning up 1 more new pod. And throughout all of this, we're still good. Everything looks good. So that's the idea of a Kubernetes rolling update. And again, this is just by saying, I want a different state. There's not really anything more to it. There's really not much work involved. Like, seriously, the entire code to do that includes a readiness probe and a liveness probe. That's it. And that's in this extreme example of something where you have a 20-second startup. Now, another use of a readiness probe is, let's say your QA or your testing process may not be quite ideal. Now, hopefully it's perfect. But if it's not, your readiness probe will detect that. It's gonna be pinging again, and it'll just never get to a state of ready. Let's say your container that you're trying to deploy is completely broken. It has bad configuration, something like that. A readiness probe just won't let that ever get out. Again, that's a great use of Kubernetes. Okay, so remember when I said I was going to break things? Well, we're getting close to that. I have a little image that I created called Mayhem, and it does nothing good other than just eat up tons of resources. And because the next step is actually just destroying everything, I first wanted to show you how to do it properly. So Kubernetes allows for resource limits, so you can say, this container can only take up 64 megs of RAM and 1/8 of a CPU. And well, that's what it's requesting, and then it can only take up 128 megs of RAM and again, 1/8 of a CPU. So if I go ahead and apply this guy, sure, okay, so I got to pull this guy back up. But it's gonna be fun to watch this mayhem deployment. It'll start running, and in not too long, out of memory killed. Okay. Then you see there's already a bunch of restarts happening for these mayhem deployments. This guy's not even getting started up. These guys keep on getting into out of memory killed. What's important though is all this time, this is still working. It's not slowed down. It's not slowed down. But yes, these guys are still out of memory killed. They're never going to start up, and that's by design. Now, on the other hand, you can deploy the same thing without resource limits. Yeah, this is not smart, but don't do this yourself. Like this is going to destroy my cluster, but it's fun. So, whatever. So we got our mayhem deployment, and this one just, as you notice, is the same thing. It just doesn't have those resource limits. So we'll see. I mean, it's going to take some time. It's going to update. Okay, we've got our new pods coming up. They're having no issues, right? Like they're getting all the resources on our system. But it shouldn't take too long for this to gradually die off. If I do, no, yeah, sure. Yeah, it's slowly going to die off here. I promise, eventually. In my testing, it took around 50 seconds for this to completely kill the cluster, but whatever. And I know I've got to move on. So just visit robertjscott.ca eventually later today, and it will be down, I promise. So yeah, that's how that works. I'm running out of time. What's the end time here? I don't know. Okay. So I'm going to be really quick and breeze through these things. Just a quick recap of the things I discussed. One, liveness probes. Those are what you can use to restart your container if it fails. Readiness probes. These will prevent traffic from getting to your container when it starts up, if it's not, until it's actually ready to receive traffic. And it can also prevent any kind of bad image or bad container from getting to your container. And then resource limits, these can be huge. Without them, you can kill your cluster, or your nodes at least. So don't let some kind of rogue container destroy everything on your system, because that can happen. No time for bonus. Affinity stuff is cool, but I don't have time for that today. But on the other hand, there is some great resources. I wanted to at least get to this part. The Children's Illustrated Guide to Kubernetes is amazing. Seriously, if you don't know anything about Kubernetes, just look at it for the pictures. They're great. The illustrations are amazing. And it actually is a legitimate introduction to Kubernetes. If you're someone like me who just likes to play around and see how things work by trying them out, one of the best ways to do that is the Quick Start for Google Container Engine. They give you something like a $300 credit just to try things out. So you can get a long ways with that for no effort. And around a year ago when I started getting into Kubernetes, this was the first thing I tried, and it sold me on Kubernetes in general. It's free. Their quick start takes around less than an hour anyways, and you have a Kubernetes cluster up and running with your own website, whatever up on it. It's a great introduction to Kubernetes. If you're just really stuck on AWS or you want to get a little bit further into things, the system we use called COPS, one of the contributors there wrote a blog post about setting up a highly available Kubernetes cluster with private topology. It's a great intro. Again, you can have your cluster up and running in hopefully less than an hour using COPS. I will add a little caveat there that COPS is amazing. It's a great starting point, but don't just use it as it is, because there's some security ramifications that their defaults aren't the best. So it's great to start, it's great to play with, but just don't completely use it as is for anything that's security sensitive. And then if I tried to do these in some level of complexity, so I think the Children's Illustrated Guide is great for everyone. On the other hand, KubeCon videos, some of these can get super advanced. And some of these are just a great overview, but the most recent KubeCon was February, March, I don't know, sometime recently. in Berlin, and there's some great videos from there, great content, and highly recommend it all. And yeah, Kubernetes is great. You should try it out. Follow me on Twitter or just look here later. I'll post the slides, so if you don't remember these links, you'll actually have them. And my website, if you want to verify that I broke it, you can check that out later. And I'm pretty sure I did, but whatever. Do you have any questions? I'm told I can give out T-shirts for bad questions. I don't know how this is supposed to work, but I mean, even if it's a terrible question. Sure, yeah, thank you. Yeah, that's great.
I noticed on your manifest that you didn't have any namespaces. Did you set your kube control namespace? by
Yeah, so
default?
this guy obviously uses Kubernetes. So what he's talking about here is okay, let's try this guy. Wow, sweet. So at the top here, you could add a namespace attribute, and that would force this pod or this deployment into that namespace. By default, what will happen is whenever you hit kubectl apply, it'll go into the namespace you're currently using. So if you don't specify a namespace here, you could use the same deployment across multiple namespaces and just switch namespace manually. But yeah, basically I'm just relying on the default there. But you're right, I could hard code that in to make sure it always goes to the same namespace. Yeah. Oh, I guess I get to get some kind of T-shirt. I don't know. I mean, whatever.
So it kind of looks like you're just running locally on your MacBook Air there, but you talk about a remote cluster.
Yeah.
Is Kubernetes set up to manage that remote cluster on AWS? Or?
Yeah, okay. I should have gone into more detail there. I'm using my personal cluster here, which is running on Google Container Engine, just because it is so easy to run on that. kubectl is smart enough. You add some kind of configuration, and it tells you what your remote API server you want to talk to is. In this case, it's Google Container Engine, and then I'm interfacing with that. So, great question.
So you said early on that Kubernetes would do whatever it takes to stand up everything that you had listed. How does it fail? What if you don't have enough resources or something goes pear-shaped? Does it fail gracefully? Do you have options?
No, that's a great question. So what's going to happen here, well, I don't know if I'm hopeful or not, but if I broke this as I wanted to, the node is basically going to, because I just threw way too much at it and just overwhelmed it, what's going to happen probably is Kubernetes, a kubelet running on that node is going to fail, and it's not going to be able to communicate. It's going to be in this kind of unhealthy state. Depending on how Kubernetes is provisioned, on AWS, it would automatically recreate itself. How I have it provisioned here with Container Engine, I basically am just going to delete this node, and Google Container Engine will spin up a new one, and that's it. But I guess the way to say it is it'll generally, it's kind of like a cattle. I guess that's a term to be used, where you can just kill things and they'll be replaced. It can fail hard, but it can recover pretty quickly. So. Yeah.
Anybody else?
Yeah, I know. So
Yeah, that's it. All right, forget it. Yeah. It's done. All right, give it up. Give it a round of applause. Yeah. Okay. All right, thank you guys, and we'll see you next week.